In this quadratic, we want to be able to extract the vertex by writing it into vertex form. This will allow us then to graph the parabola. So in order to write in the vertex form, it has to be into this form right here, this f of x equals a times x minus h squared plus k. Once you have it into that form, we can extract the h and the k. The h and the k will give us the x and y to our vertex. So in order to do that, we're going to take our original problem, 3x squared plus 18x plus 30, and keeping in mind that you can't move any of the current terms over to the left-hand side because of that f of x. We're starting with an f of x. We want to end up with an f of x. So the first thing I'm going to do is I'm going to group my a and b terms. So 3x squared plus 18x, and we have this plus 30. Okay, the first thing I need to do whenever I complete the square, because I'm using completing the square to get the vertex form, is I'm going to factor out the 3 because I know a's got to be equal to 1. So we have 3 times x squared plus 6x, and I'm going to leave my current c term alone. We're just going to push it off to the side. Now that we have a and b grouped together, and the a term is equal to 1 by factoring out the 3, we're going to then complete the square. So let me rewrite this. We have 3 times x squared plus 6x, all plus 30. In order to complete the square, we're going to take half of b and square it. So half of 6 is 3. So half of 6 is 3. 3 squared is 9. So I just added a 9 to the problem. So like our completing the square problems, we have this balance. On our balance, we just added 9 to one side. And in reality, we didn't add 9 to that side because if we distribute this 3 times x squared gives us 3x squared. So if you go back up to the original problem, it's a 3x squared. We have a 3 times 6x. 3 times 6x is 18x. And then we have 3 times 9. 3 times 9 is 27. So really, we didn't add a 9 to the problem. We added a 27. So now our equation's unbalanced. In the past, what we would have done is we would have also added 27 to the other side of the equation, again with the equal sign being in the middle. The issue that we have here is we can't change this f of x. We have an f of x to begin with. We want an f of x now. We don't want an f of x plus 27. So the only other option to balance out this 27, so again, I'm going to erase the 27 on this side because we can't change the f of x side. The only other option we have is to subtract 27 from the side that we're on. So again, right here, 3 times 9 gives me 27, so I added a 27, and I'm going to do a negative 27 to the same side, so I'm going to subtract 27. So in reality, between these two parts, so we have 3 times 9 is 27, so we have positive 27, and we have negative 27. So we have negative 27, and if I put those two together, it really gives me a 0. So I just added a 0 to the problem. I didn't add a positive 27 or a negative 27. You put them together, we get 0. So I'm not changing the original function. Now I'm going to clean this up a little bit. So we have 3 times, and we know this is now should be a perfect square trinomial because I completed the square, and 30 minus 27 is 3. So to factor my perfect square trinomial, this x squared plus 6x plus 9, I should have two binomials that are exactly the same. So I have x plus 3 and x plus 3. And I know from completing the square that the relationship between this b term and the last terms is always half. So 3 is half of 6. And then I'm going to rewrite it as a binomial squared, so x plus 3 squared plus 3. So we're almost there. And if you look at our form up here, I notice that I'm supposed to have a minus sign before the h and a plus sign before the k. Well, I do have my plus sign before the k, but I don't have my minus sign before the h. So we have 3 times, and I'm going to change that plus sign into two negatives. Because again, just like every other part of this problem, our goal isn't to change it or to solve for anything. It's to manipulate how the problem looks so that I can extract the vertex. So I knew from the original form that I needed a minus sign after the x, because it's the inverse. When we're looking for horizontal transformations or movements or translations, horizontal is always the opposite. Inside these parentheses is the opposite. That's why there's a minus sign there, because it's the inverse of whatever h is. So there was a positive 3, now we have a negative 3. And now, since we have it into the right form, so I have f of x equals 3 times x minus negative 3 squared plus 3. So let's compare that to the original form that we were looking for. So we have a times x minus h squared plus k. So my a value is 3. We have our x minus in both situations. H is equal to negative 3. We have our squared plus, and k is equal to 3. So now that I have it in the vertex form, I can extract the vertex. So again, my vertex is hk. We know h is equal to negative 3, k is equal to positive 3. So I have a vertex at the ordered pair, negative 3, 3.